Every day, more than 250,000 new cars roll off production lines around the world. From compact city vehicles to luxury sedans, rugged pickup trucks, and high-performance electric cars, modern automobiles are among the most complex machines ever built for everyday use. But have you ever stopped to wonder how these engineering marvels are actually made? How does raw steel become a finished vehicle capable of carrying families across continents? How do thousands of components, manufactured with microscopic precision, come together to create a machine that can safely travel at highway speeds for hundreds of thousands of miles? And perhaps most incredible of all, how do factories produce a new car every few seconds with astonishing consistency? The answer lies inside some of the most advanced manufacturing systems ever created: gigantic robotic arms, artificial intelligence, laser-guided inspection systems, automated logistics networks, and thousands of engineers working behind the scenes to perfect every detail. Today, we're going behind the scenes of modern automotive manufacturing to uncover the incredible technology, machines, and engineering processes that transform raw materials into the vehicles driving our world. This is how modern cars are built inside the world's most advanced manufacturing systems. The automotive industry is one of the largest manufacturing sectors on Earth. Every year, tens of millions of vehicles are produced across thousands of manufacturing facilities spanning North America, Europe, and Asia. Some automotive plants cover millions of square feet, larger than entire city districts. Inside these facilities, manufacturing never truly stops. Parts arrive around the clock. Robots operate day and night. Production schedules are planned months in advance. The challenge is staggering. A modern vehicle contains thousands of individual components. Each part must arrive at the correct location at precisely the right moment. A single missing component can disrupt an entire production line. To prevent delays, manufacturers rely on highly sophisticated logistics systems. Many factories operate using just-in-time manufacturing. Instead of storing massive inventories, components arrive only hours before installation. This reduces costs, improves efficiency, and keeps production moving at incredible speed. But before a vehicle reaches the assembly line, years of engineering work have already taken place. Long before the first piece of metal is cut, every vehicle begins as an idea. Engineers, designers, software specialists, and manufacturing experts collaborate to transform concepts into reality. Modern vehicle development relies heavily on advanced computer modeling. Using powerful simulation software, engineers can test crash performance, aerodynamics, structural strength, and efficiency before a physical prototype is ever built. Virtual testing saves enormous amounts of time and money. Thousands of digital crash tests can be conducted in a computer environment before a real vehicle ever impacts a barrier. Aerodynamics specialists analyze airflow around the vehicle. Even minor improvements can increase efficiency and reduce energy consumption. For electric vehicles, software engineers optimize battery performance and power management systems. The modern automobile is no longer just a machine. It is increasingly becoming a rolling computer network. Once engineers finalize the design, production planning begins. Every component, every weld, every bolt, every robotic movement must be carefully programmed before manufacturing starts. Only then can raw materials begin their transformation into a finished vehicle. The journey begins with enormous coils of steel and aluminum, some weighing several tons. These massive rolls enter high-speed stamping facilities. Here, giant presses exert thousands of tons of force. Within seconds, flat sheets are transformed into doors, roofs, fenders, floor panels, and structural components. The precision is remarkable. Measurements are often accurate to fractions of a millimeter. Modern presses can produce multiple parts every minute. After stamping, components move to the body shop. This is where the skeleton of the vehicle begins to take shape. Thousands of metal components must be joined together. Traditionally, this required extensive manual labor. Today, robots perform most of the work. Robotic welding cells operate with incredible speed and precision. Sparks illuminate the factory floor as machines perform thousands of welds on every vehicle body. Each weld contributes to structural strength, crash safety, and long-term durability. Laser measurement systems constantly monitor alignment. Even the smallest deviation can be detected instantly. Within a surprisingly short time, hundreds of separate metal pieces become a single vehicle structure, known throughout the industry as the body in white. The car is finally beginning to take shape. Perhaps the most fascinating aspect of modern automotive manufacturing is automation. Some production facilities utilize thousands of robots working together in carefully synchronized systems. These machines never tire, they never lose focus, and they can repeat tasks with extraordinary consistency. Robots perform welding, painting, material handling, inspection, and even complex assembly operations. In many facilities, autonomous transport vehicles move components throughout the plant. Using sensors and navigation systems, they transport parts without human drivers. Artificial intelligence is increasingly being integrated into manufacturing processes. Computer vision systems can inspect surfaces for defects faster than human inspectors. Machine learning algorithms analyze production data to predict equipment failures before they occur. The result is higher quality and greater efficiency. Yet despite all this automation, humans remain essential. Engineers oversee production systems. Technicians maintain equipment. Quality specialists verify standards. Modern manufacturing is not humans versus machines. It is humans and machines working together. Once the vehicle body is completed, it enters one of the most important stages of production, final assembly. This is where thousands of individual components come together. The painted body moves along carefully planned production lines. Workers and robotic systems install wiring harnesses, dashboard assemblies, seats, windows, electronic systems, suspension components, powertrains, and countless other parts. Timing is critical. Every station performs specific tasks within strict production windows. A delay at one station can impact the entire line. Advanced manufacturing software coordinates operations in real time. Many factories can produce multiple vehicle models on the same assembly line. One vehicle may be gasoline-powered, the next could be electric. Yet both are assembled efficiently using flexible production systems. As the vehicle progresses through final assembly, it begins to resemble the finished product customers will eventually drive. But before leaving the factory, one final challenge remains: quality verification. Modern vehicles undergo extensive quality inspections. Laser scanners measure body dimensions. Computer vision systems inspect paint quality. Electronic diagnostics verify software functionality. Water testing chambers simulate heavy rainfall. Brake systems are tested. Lighting systems are verified. Sensors are calibrated. Some vehicles undergo dynamic testing on specialized tracks before shipment. Manufacturers know that reliability is essential. A single defect can affect customer trust and brand reputation. This is why quality control remains one of the most important stages of production. Looking ahead, automotive manufacturing continues to evolve. Artificial intelligence is becoming more sophisticated. Factories are becoming increasingly connected. Digital twins allow engineers to simulate entire production systems. Collaborative robots are working more closely with human operators. And electric vehicles are driving major changes across the industry. The factory of tomorrow will be smarter, faster, and more automated than ever before. The next time you see a car passing by on a highway or parked quietly in a driveway, take a moment to consider the extraordinary journey that brought it into existence. Behind every vehicle lies a world of engineering, a world of innovation, a world of precision measured in fractions of a millimeter, thousands of people, thousands of machines, and countless hours of research, design, and manufacturing expertise. What appears to be an ordinary automobile is actually the result of one of humanity's most sophisticated industrial achievements. From raw steel and aluminum to intelligent robots to advanced manufacturing systems operating with incredible accuracy, modern automotive production represents the intersection of engineering, technology, and human creativity. And as automation, artificial intelligence, and electrification continue to transform the industry, the cars of tomorrow may be even more remarkable than those we drive today. The future of transportation is already being built, and it begins inside the world's most advanced manufacturing systems.